Hello and welcome back to the series where we are learning how to build great command line applications in Go. For the past 1 week, I have published, I think about I published 6 videos and you can see everything here. That's why I'm showing you the playlist. But something is still missing, and that is how do you run external programs from your own Go program, like the other command line programs. How do you execute them from your program? So I want to show you an example of what I'm talking about. For example, let's say this program ls, how do you run it from your program? How do you run ping, for instance? How do you run it from your program? You can not just running the program, but you also need to control the arguments or the parameters that the program accepts. That is what we are going to learn in this video. Let's go straight into it. Let's create a folder called runner. Another file inside the folder. Looks good. We need almost very simple. Running external program from your Go program can be really simple, right? We need the os/exec package in order to do that. So let's do some simple stuff. The program we are going to run is called ls. Args, the argument we are going to pass to the program, for now, nothing. Then let's call it, I can call it ls first. Then we call os.exec. Let me fold this one. Os, so exec, like this. So it's coming from this package os/exec for execute. Now the name of the program you want to execute and the args. Now, before we run this program, I want to say something that is really important. When you run external programs from your own program, you are exposing your system to a very high risk. So if you accept command or if you accept input from users or even other programs, you must validate or sanitize those inputs to avoid breaching of your system. It is really important. I am not responsible for anything that goes wrong with your system. I won't be held responsible for anything that affects you, cause you any kind of loss. This is for educational purpose. Running program this way can be really dangerous, but of course, the Go programming language provides us with the utilities to run external programs from our own program, and that is why I'm providing this tutorial. So it is really important for me to mention this, and if you think you don't really understand or you don't find it safe, you can stop watching the video or find a different way to do what you want to do. It's time to code. All right, so this time we're going to run the ls. So imagine, basically, if you come here and you type ls, look at the result, right? The same thing that we are going to do from the program. So ls, we can say the output of the program now will be ls.output. We also need to capture the error. We're going to check for the error. If we have any errors, we basically want to stop the program here because you can't do anything else. Else, nothing special for now. We just print the result, which we can convert to string because output returns bytes. Okay. This is our first program. I will go ahead. I just open my terminal, type go run runner, and you see the result of ls command. Now, when you run ls, I think you can run ls like this to print it this way. If you want, you can do like this to print hidden files like this, right? When we run the program the first time, there were no hidden files. So let's pass some arguments by passing the -a flag. Then I run it again. This time around, you see, we have the hidden files. Great, we made progress. Quick recap. The most important thing is knowing the package, which is os/exec, and you call command, pass the command that you want to execute, and the command arguments. If you have multiple arguments, you can separate them, here like this. And then you capture the output. There are many ways to capture output. There is something called combined output, which is basically so when you print, let's take a step back a minute. When you print something to the screen, you can print to standard output or standard error. For these, both standard output and standard error are printed. They are printed to this using this same combined output. That is what they have done here. So you see that they are using the same buffer to capture the outputs. So if you want to do that, you can use the combined output. But for us, the output is fine. If you look at the output, you see it's only std out that they're capturing here. One good thing about Go is you can see the source code, right? You can see the source code of the program. It's important to sometimes read the source code, because if you look at the program, when we call output, it calls another object called run, which actually does the running. But because they use this to simplify the process for us, so this is really important. I'm not trying to rush through the video just to show you fancy thing and then exit. That is what most people do on YouTube. I'm not interested in that. If it is just one person that watched the video and learned something from it, for me that is okay. That is fine. All right, so this is it. Now let's turn this into a small program for us to run something. Let's turn it into a small program. Let's define a constant here called exit, something that when they type the exit, we can close the program. And I will start a func here. Okay, prompt. This is the string that we are going to display on the terminal. And then the in is where we are going to read data from. So we want to continue just like let me show you what we are going to do. This is Python. Python stays like this. Then you can keep typing command like import os, import something, time, anything, right? So this is what we are going to do. Something like this. We are not building Python, of course. So we are going to get data from io in, io.reader, and out will be io.writer. We don't need to return anything, right? The reason why I am requiring io reader and writer instead of something else is this is for flexibility, and it makes testing a whole lot easier, because these are interfaces and you can mock it really simple to mock. And for me, you want to program to an interface instead of concrete implementation. So let's do it. First thing I want to do is to grab the scanner from buff.io, new scanner, and then we give it the in. And this is what I was saying. If you look at scanner just requires io reader. So this is the same thing the Go community is doing as well. Really great way of programming. Now we continue to loop. In the first iteration, we want to print the prompt, which I can just print so that we have it like this, prompt. And then after that, we call scan. Let's call this one .scan. If we are unable to scan, we can just exit the loop. Now we can read the line, like when someone type and press enter, we can get that line. So we get that line from scanner.text. You see, everything is making sense. It reads really well. We are no confusion, right? I hope there are no confusions. I'm taking it line by line, step by step. So if the line is equal to our exit, or the line is just empty string, we want to os.exit. We just want to exit the program here, and we can print something to the fprint. I think just fprint is fine. We print something to out and say program closed. All right, that's it. Then what next? We can let's split so we can say parts strings dot split. We give it a line and we split by space. I think there is a bytes.field, something like that. Another package, another function, but this works. If the part, we want to make sure at least we have something. Ideally, we should be fine here, since if this is an empty string, we are going to have a problem. But let's still try. If this is 0, we are going to exit the program as well. But this time around, for me, is an error. No input. Okay, after that, we are good. After that, the command will be the first thing in the list. So, for example, if they type ls like -a, for instance, and we split them into 2, the first one here will be the command. Everything else will become the args. What I'm going to do about the arg is to do args, take everything from the part, take from the first index up. That becomes the argument. So we are excluding the first one, which we have extracted. Take from the first index to the last. Now, so we need to now call the runner exec command. We pass it the command and the args. You see, the same thing we did. Everything else we have done here is just pre-processing. We are trying to form the code. Now, after that, result error runner. I will do combined output here. We check for errors. We can bring this code here. This time around, we want to do error like this. Okay. At this point, we are good. We can write the data that we have received in the writer here. And that's it. This is our program. To run the program, it's very simple. This was the first program. We no longer need this. We're comment it out. Then I'll call start. Let's give it a prompt. Let me give it like Python kind of prompt, but this time around 3 arrows. Our input will be os.std_in and output will be os.std_out. os.std_out. And that's the whole program. Okay, time to test it. Let me expand this terminal. Go run runner. Great, so this is our prompt. We can say ls. Great, you see. We can do ls-a. We see. We can do, let's do make -p example/text/sample/test/another something. This is, now we're running the command with arguments. Press it I can do 3 dots, and let's see. You see how fantastic it works, right? And this was the make dar that we executed, and everything was created. Really good. But something is it's not going to work. Let's say ping google.com. You see, no output. This one is tricky, and we are going to do it. All right, so that's what we are going to do next. All right, let's start by creating a folder called runner 2, and we create a main.go in the folder. Basically, in order for us to continuously capture the output of one program and then print it out, we need to be in a Go routine. But it's actually way more complicated than that. Each command that you execute has a standard output, which is the sort of the happy path, and then the standard error. But most times, because we see both output on our terminal, some people are unable to distinguish between standard output and standard error. But when you are dealing with a program, you have to be able to know it. Let's start by creating a type. Basically, we are going to use this custom type to capture the output from standard output of the command and also the standard error of the command. Let's do it. I will type let's say custom writer. If you are a little bit confused, please bear with me. You will need time to process it. And what I'm going to do is to have a buffer here and then the writer. What we are going to do basically is to save like a copy of the data in our buffer and forward it to this writer. But let's see how it goes. Let me create a func, new custom writer. Writer here. What else? I need to return pointer here. So, okay. This is a simple constructor, nothing special. Let's fold the code so we can have more space. What we need to implement this method, which is basic stuff in Go, func, right, and what are we going to do? We're going to call the buff.write. We write the data, and we call the underline writer, which is, where is it? This is W. Not right, and we call it back with P, but we need to return it. Okay, that's it. Now we need to fold the code again, and let's add just another method called bytes. Just a very simple thing. And bytes return bytes. It's basically w.buff.bytes. These are just helper methods. This one is really for us to print something out later. Okay, so we have this. This is the most important thing here. All right. Next is to write the code itself here in the main method. All right. Let's start with the command we want to run. Exec command. Remember, we wanted to run ping. I can give it Google. What do we want to do? Here we need to set up some data, which I'm going to call stdout, std root errors. Now, the command is going to have two connected pipes, one std out and std error. So we needed two pipes. So cmd std out. Sorry, I forgot to call the command that std out pipe std error in. This almost same thing, but this time is std in. Okay, both are connected to the command. This is what I said earlier, that each time you run a command, you have access to std out and std in. So we get that. Now our std out now we are going to use this os.std out, and then our std in, the same, but this time std error here. Yes, and then I get it from std error. Okay, nothing complicated so far. We're doing this so that we can capture the data that is going to be written to. Remember, when you go to ping google.com, this is being written to std out, right? Let's say we go to, let me type some kind of domain that I know doesn't exist. This probably was written to std error. I don't know, but it depends on the designer of the program, but most likely the error was written to std error. But we want to be able to capture both. Okay, that's why we're setting up like this. After that, we are going to start the command itself. Command.start. Okay, so far so good. Then we check for error, of course, all the time. This one is simple. Okay, after the error check, let me make some room space here. After the error check, let's grab a wait group from the sync package. So I'm going to just tell the wait group that we are going to run a single Go routine here. And in that Go routine, we are going to do really simple stuff. Error std out, this one, equal to IO copy. The destination is our std out, and we want to copy from the std out in, this one. So from the pipe, remember this is what the program is connected to. So we are going to copy from there into this one. And don't forget, this one is what we are capturing. When we copy into this one, in our implementation here, we are saving a copy of it to the buffer. That is the trick, and then forwarding it. That means what we can do with that is, we have access to it when we call these bytes. Okay, after that, when we are done, we call the wait group done. Don't forget this, so you can decrement the counter. If only I can type very well. Okay, that's all with the Go routine. Next step is we need to copy for the error. We need to copy for this as well. IO copy. So we are going to copy from std error. Sorry, we're going to copy from here now into this one, the second one. So you see that is really straightforward. Let me see why we cannot use of type closer. Let's see why we're having errors. Okay, let me see where I'm making mistake. Okay, so I found the error. I made a mistake here. I should be connected to STD error pipe. Yes. You see? After that, we just do wait group.wait so we can wait for it. Now we're waiting for the program to execute and all that. So after that, cmd.wait. Okay. If error is not near, honestly, I'm going to copy the same one here. All right, then we have to check for error. If error std out is not near, or error std error is not near, both of them have something or one of them has something. Basically what we want to do is to also log theta, but we can't do this, so we need I will do theta f here, theta f, which I will do this way. So this and this. That way we capture the right data at the right place. All right. After that, we can do the output string error string. We can basically these two pipes now we need to grab the data from them. So if you don't be confused, I'm doing it on the single line. There's nothing special here anymore. In short, if we don't want to do that, we can go ahead and print it out directly. Let's print it. Printf. I can now say out. I'll put a new line like this. Then I'm going to print the out, and then after that I'll print a new line. Then in case we have any errors, I'll say error, new line, then this error string and new line. So it will be std. Let me make sure we grab the correct one. It's a byte, so we can call string dot bytes. After that, we grab the one for errors, string, and dot bytes. Okay, let me bring this down and look at the code one more time. We started with a custom writer, basically for us to capture some output. The output can come from std out or std error, no problems. We did the implementation of the writer here by taking a copy of the data into our buffer, and then we forward the write to the underlying writer. After that, we have a helper method to return the bytes. We set up our command. This is what we want to run. It can be any command actually. Then these are errors that we defined, nothing special. Now when our program is going to have these pipes connected to them, we grab the pipe. We also set up two instances of our writer, and then we started the command. We added the wait. We started another go routine to copy data from std out into our writer here. We did the same thing for error, but this time on the main go routine. We waited for the command, then we print. All right, let's run it and see. If there is any problem, we can come back to debug. That is a form of programming. Go run runner 2. Fingers crossed. Okay, and our data is coming in. looks good. Let me press interrupt to stop the program. Our data is coming in. How about let's look at in here. I want to do something. Let's give it a bad program, something like this, to see what happens. Okay, and exec blah 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 failed to execute. So it failed. I think it failed right at this point. It failed right at this point. All right. And okay, let's give it ping again. And this time around, I'm going to start the program and go and turn off the internet. And let's see what happens. Yes, internet is off. And we're still getting some, okay, internet is off, but at the same time it's back on because my phone is connected. So I can unplug my phone. All right. And we are still getting output. So this looks great to me. There's a lot of room for improvement. But in a nutshell, you know that in order for you to continuously capturing data, you need to be in a Go routine. You can do your own writer and copy the data. So this will be it for now because the video continue to be getting longer and longer, and then I think we can stop at this point. So this is the program. Let me reduce it. It's very few lines of code. This is everything in main. This is everything in main, right? I'm trying to reduce the font size. Yeah, this is everything in main, and the rest is just the simple writer that we implemented. So that's it. Thank you for watching. Thank you for for learning with me, and I'm so grateful that some people send me messages to thank me. It's not easy, but we continue to learn, and then see you soon. Bye.